Hey there everyone, welcome back to OneCodeCamp. This is Justin, and in today's video, we're diving into the basics of Java programming. Programming is all about making decisions and controlling the flow of your program based on conditions. This is where control flow statements like if-else come into play. They allow your program to execute different blocks of code depending on whether a condition is true or false. Let's start with the simplest control flow structure, the if statement. This evaluates a condition and runs the code inside the block only if the condition is true. In this example, we have a variable age set to 18. In this condition, we have an if block. This checks if the age is greater than or equal to 18. If it is, it runs the code inside this block. For example, let's run this. We can see in our terminal that it prints the statement inside the if condition. That is because we have satisfied the condition inside of this block. For example, if we set this equal to 17, this would make this condition false. Since this condition is now false, it will not run the code inside of this block. Let's try hitting the play button again to run Java. And you will see that we have no output since it does not satisfy our condition. But what if we want to handle two cases, where the condition is true and when it is false? That's where the if-else statement comes in. Let's have an example here. Let me change the variable. Let's say we want a number. Set this equal to 10. And let's say if the number is greater than 0, then we will print that the number is positive. Like I said, we will handle two cases here. What if this condition is false? So let's add the else keyword and then print the number is not positive. Okay, so in this example, we check if the number is greater than 0. If it is, we print the message saying the number is positive. Otherwise, we print it is not positive. So let's see and run this. As you can see, since we set the number equal to 10, the number is positive. Since it satisfies this condition, it will run the block here and stop the program. Let's say we change this variable to a negative value, -1 for example. If we run this, you will see a different output. The number is not positive. That's because the number is set to -1 and -1 is not greater than 0. That's why it will skip this condition and it will run this line of code under the else block. The number is not positive. Again, if we change the number variable to a negative value and run the program, we can see that the output changes. Sometimes we need to evaluate conditions inside other conditions. This is where nested if-else statements come in. Let me show you how it works. Let me clear this first. And add a comment here. So this is for nested if-else. Let's declare a variable, age, and set this equal to 20. And say, if age is greater than or equal to 20, or for this example, let's say this is equal to 18. And then inside this if block, we will nest another if-else block. So for example, if age is greater than or equal to 21. We will print you are an adult and can legally drink alcohol. Just legally drink. And then let's add an else statement here. Let me close this for now. You are an adult, but cannot legally drink alcohol yet. Okay. And then we can add another else statement here. You are not an adult. All right. So let me break this down for all of you. So in this example, we nested an if-else statement inside another if-else statement. If this is the case, this is called a nested if-else. So first, it will check this condition, and if it is true, or if the condition here is true, it will go inside this if-else block. And then it will check again if the condition is satisfied here. If it is, it will run this code. Otherwise, if this is false, we will run this code. And then we will end our program. However, if inside this if statement, the result of this Boolean statement is false, it will automatically run this statement in the else block here. Okay, so let us run our example. So we set our age equal to 20 and then run this. As you can see here, we have a result. You are an adult but cannot legally drink alcohol yet. Let's examine how we got this result. So our age is 20. So this first condition is being checked. 20 is 20 greater than or equal to 18? Since this is true, we will run or we will go inside this block. So now we will check if 20 is greater than or equal to 21. So 20 is not greater than or equal to 21. That's why we will go to this else block and run this statement. Okay. For example, we set this equal to 22. Let's run this. You will see that we have a different result. You are an adult but can legally drink alcohol. Let's examine this. Since our age is 22, we will satisfy this condition. Age or 22 is greater than or equal to 18. And then we will examine this block. Is age greater than or equal to 22? Yes. Since it is true, we will run this block of code and exit our program. As you can see, you are an adult and can legally drink alcohol. And then, let's try setting this equal to less than 18. Let's say 70. If we run this, you will see here that we have a different result. You are not an adult. So since 17 is not greater than or equal to 18, there's no need for us to go into this block. Instead, we will proceed to the else block here. That's why we have a result of you are not an adult. So again, to summarize this checks multiple conditions in a structured way. So for example, if the age is equal to 20, the first condition evaluates as true, but the second one does not. That's why we have this output here. Now, what if you need to check multiple conditions, one after another? Instead of nesting, you can use an if-else, if ladder for better readability. So again, let us delete all of this code. Again, we call this the if, else if, else ladder. Let's say we have a new variable of score. Set this equal to 85. Let's add some conditions. If score is greater than or equal to 90, we will print grade is equal to 8. So we want to check other conditions. That's why we will use the else if keyword. So this allows us to add another condition here. So let's say if score is greater than or equal to 80, we will run this block of code or this line of code. Grade is set to B. Let's add another else if. Let's say if score is greater than or equal to 70, let's print grade is C. Next, else if score is greater than or equal to 60, we'll print sys out grade is D. Then lastly, if all of these conditions are not satisfied, this will be our catch-all statement. Okay, this will be run. Grade is equal to F. All right, so this example assigns grades based on the score. So we will notice how the conditions are evaluated in sequence only if the first true conditions block is executed. So let's run this. Okay, let's evaluate this and break down our code. Our score is set to a value of 85 here. So it will check the first condition. Is the score greater than or equal to 90? Since 85 is not greater than or equal to 90, this will not be executed, and it will run to the next condition. Now we will evaluate, is 85 greater than or equal to 80? Since the answer to that is true, we will have this result. As you can see here, we have our grade of B, and the program will be ended. For example, let's say we have a value of 75. Run this. The same thing happens. It will run from top to bottom. It will first check if the score 75 is greater than or equal to 90. Since the answer to that is false, it will check the next condition. Since 75 is not greater than or equal to 80, it will skip this condition and check this one. The next condition here is 75 greater than or equal to 70. Since the answer is true, our program will print or run this statement. Grade is equal to C here. So if all of the conditions here are not satisfied, let's say, let's assign this a value of 25 and run this. As you can see, this condition is not satisfied, as well as the other conditions that we have here. So we will have this line executed under this else statement. The grade is equal to F, as you can see here. We can also combine multiple conditions using the logical operators we used in our previous video. We have the AND operator and the OR operator. This makes your conditions more powerful. Let's see an example. Let me first clear this. This one, we will use logical operators. And if-else statement. Okay. So for example, we have a new variable, let's say a temperature. Set is equal to 25. Let's check if temperature is greater than 20 and temperature is less than 30. So we're making use of our AND logical operator here. So if this condition is satisfied, it will also check here. If both of these conditions are true, this code under this if statement will be executed. So for example, let's print out the weather is pleasant. Let's add an else statement here. And print the weather is not ideal. Okay. Again, since we're using this AND operator, both of these conditions must be true in order for the entire condition to be true and execute this statement. So our temperature is 25. Temperature is greater than 20. Yes, it is true. We will check this. Is 25 less than 30? It is also true. So this statement will be executed. Let's check this by running this program. As you can see here, since we have satisfied both of these conditions, we will print the weather is pleasant. Otherwise, let's add some or change the values here. Let's say change this equal to 35 and run our program. As you can see, we have a different result. Again, let's evaluate how we get this result or how we got this result. Our value is 35. 35 is greater than 20. Yes, it is true. However, like I said, when we use the AND operator, both of these conditions must be true in order for the entire Boolean statement to be true. Since 35 is not less than 30, this will result to false. So we will run the statement under the else block here. The weather is not ideal. Now, let's move on to the switch case statement. This is a cleaner way to handle multiple conditions when you're working with a single variable or expression. Let me clear this. Now we will talk about the switch case. For example, we have a variable int day equal to 3. And then we will check if this day is either Monday, Tuesday, Wednesday, Thursday, or Friday. Let's say our day 1 is Monday, day 2 is Tuesday, and day 3 is Wednesday. Okay? For example, let's use our switch statement here and then evaluate this variable, day. So if the case is 1, we will print system.out println Monday. Then for each case, we'll have to add our break statement. So I will explain this later on. Don't forget to indent this. And then let's add our second case. Let's say case 2. So if the value here is 2, we will execute the next command, or the command under this case, which is Tuesday. Again, let's add our break statement. So let's add our third case. It is Wednesday. Let's say, let's add our break first. And then let's add our fourth case. Case 4. System out print line Thursday. Let's break this and add our case 5. This cases refers to the value of the variable that we add here in our switch statement. So if the value is 5, we will execute this block of code. This one is Friday. Let's add our weekends as well. This one is Saturday. We have our case 7. Then this one is for Sunday. And then if we have a value that is not 1 to 7, we can have our default. So this will be run if all of these values are not equal to the value we set here. Okay. Since this is the last statement, we don't need to add a break statement. So in this example, this example maps the integer value to the days of the week. The break keyword ensures that the only matching case is executed. If we don't have this, for example, let me remove the break statement here. So since we have the value of 3 assigned today, it will evaluate the day and it will match the case 3 since we have 3 as our value. So it will execute this. Notice that we remove the break statement. Notice what will happen. So it will print the next lines under this statement. So if we add the break, this will end our cycle. So instead of printing Thursday, after it prints the Wednesday, it will break from the switch statement. So let's run this again. So as you can see, you can only see Wednesday here. Then, as I said, the default case acts as a fallback if no other case matches. So for example, let's assign a value of 8 here. So since we don't have a case for 8, this will be our line that we will execute. Invalid. So you can change the value of the day to test different outputs and remove the break statements to see how Java behaves when they are missing. Today, we've covered if-else statements, nested if-else structures, the if-else-if ladder, and the switch case statements for managing multiple conditions efficiently. In the next video, we'll dive into the loops in Java. It is crucial, it is a crucial concept for automating repetitive tasks. Be sure to like, comment, and subscribe to OneCodeCamp to keep learning Java step by step. See you in the next video.